So one of the things we think we understand about psychic awareness is through extrasensory perception, we have the ability to perceive things at a distance. We can gain knowledge from a distance or from shielded areas. Well, okay, the interferometer is a sealed optical system. You can't just look at it. It's inside a box. So you tell somebody, use your extrasensory perception to gain knowledge about what these photons are doing. That's the measurement then, because now you're doing what you need to do, which is observe, in this case happens to be the mind's eye, and gain knowledge about what happened. Well, it's a very difficult task because we can't see a photon as it's flying through the air, and there's a whole bunch of things we can't do with our eye, but maybe you can do it with your mind's eye. And so if you found it too difficult, and I told this to our participants, if you find it too difficult to imagine what's happening with the photon, then just imagine you can mentally block one of the slits. Well, that would force it to kind of go through the other one. Or just like take the laser beam and nudge it over a little bit so it's going through one slit more than the other. Do any strategy you can think of in order to mentally interact with this system and either gain knowledge from it, which is like pulling information out, or pushing knowledge in, which is pushing information in, like pushing the beam around. So that's what we told people to do. And the reason why meditators did better than non-meditators is because they can maintain their attention on a task for more than 2 seconds. Whereas the average person mind wanders almost instantly, and so they just can't do the task.
Thank you for joining us here on Connecting with Coincidence. Today I'm speaking with Dean Radin, a physicist and consciousness researcher whose new book, The Science of Magic, explores the mind, that the mind can directly influence matter. The mind can directly influence matter. That consciousness may literally collapse the wave function, and we will talk about what wave function means. Dean's experiments bring rigor to what we used to be myth, telepathy, intention, and synchronicity measured under controlled conditions. My own work approaches the same mystery from a different angle. Rather than seeing consciousness as a force that collapses probabilities, I treat it as an organizing field, a living coherence within which events find meaning. Where Dean studies magic as a measurable effect, I studied as a psychological and ethical process through the collective human organism learning to observe itself. So our conversation today bridges experiment and experience, physics and psychotherapy. We'll ask together, does consciousness make reality or does it discover it? How might that difference in our understanding shape humanity's next stage of its self-awareness? So, welcome to our show, Dean Radin, and I will tell you a little bit about Dean.
Thank you.
So glad to have you with us, Dean, and you and I are going to be talking on another show next week. And this is going to be fun to continue what we do here. So who is Dean Radin? He's very well known in parapsychological research. He's chief scientist at the Institute of Noetic Sciences, IONS, associated distinguished professor at California Institute of Integral Studies, and co-founder and vice chair of the neuroengineering company Conagenics. He earned an MS electrical engineering and a PhD psychology from the University of Illinois Urbana-Champaign. In 2022 was awarded an honorary doctor's degree, Doctors of Science, from Swami Vivekananda University in Bangalore, India. He's written a lot of books, done a lot of papers, and his current book, The Science of Magic, is just currently out. So I recommend you take a look at it because Dean knows how to bring science to consciousness in a way that very few other people do. So welcome to the show, Dean. It's great to see you again and be able to talk with you.
Thank you. It's a pleasure to be here.
Well, one of the fun things about your life was a coincidence involving your search for a lab space. And you've told the story many times, but I think we may come at it from a different angle today. So, would you just tell us about how you confirmed Rumi's idea that what you are seeking is also seeking you?
I think it also is relevant to our understanding of magic, which is one of the reasons why I repeat that story in my current book. So the story is that in the year 2000, several colleagues and I were looking for a place for an office to create a nonprofit institute for psychic research. So this was during the dot-com craze in Silicon Valley, and we had to keep moving further and further away from Silicon Valley Central, and ended up with a kind of a strip mall with professional offices, real estate and dentists and things like that in Los Altos, which is a suburb of Silicon Valley. So we found a place and we said, okay, this looks okay. Uh, I would go to that office in a certain direction, and I would park, and there it was. We were right on the end of this mall, so I didn't need to look at who our neighbors were. One day, a couple weeks after we were already there, we walked to the office a different way, and I passed a office that had a sign that said PsyQuest Inc. PSI Quest Inc. To which we thought, oh, that's a funny synchronicity because we're doing psi research and there's some company here that has the word psi in it. So we figured it probably meant something like Personnel Services Incorporated or something like that, because what else could it be? And it looked like a normal office. Nobody in there that I could see. So every so often I would walk past that way, hoping to see somebody in there, and never saw anyone. Then I would walk to work a different way, and I happened to pass our neighbor office, which the first time I had gone that way, and noticed it said a little sign, PsyQuest Labs. And now I'm more interested because it was clearly the same company, but it had a laboratory, which happened to be right next to ours. And we were laughing amongst ourselves and the other colleagues. Why would personnel services require a laboratory? Well, we didn't know, but we thought, well, we better find out. So I started walking that way every day and would knock on the door and look and kind of peek through the blinds. Never saw anybody there. In fact, even in the other place, I never saw anybody anywhere in those two offices. Finally, one day, months later, I see somebody's in the lab next to us, and so I knock on the door opens. There's a man who opens the door, and he looks at me and looks shocked, like he's looking at a ghost. And so I didn't know exactly what to do because that's not usually the response that you expect to get when you knock on somebody's door. So I said, hello, I'm your neighbor next door. I just wanted to introduce myself. My name is, and he says, kind of croaking, Dean Radin. And now I'm shocked because I don't know this guy and he knows who I am apparently. So I ask him, well, yes, but well, what are you doing here? Because I want to know what the laboratory is. And his response was, I'm doing what you're doing. What am I doing? Psi research. You mean like what we do? Psi research? Yes. So to make that part of the synchronicity shorter, it turns out that he was an Apple employee. He was involved in one of the developments of their first laptops, and he cashed out of Apple to start a psi research company with a laboratory doing what we were doing because he wanted to commercialize it in some way. And so he was engaged in a process of yoga nidra, a variation of that, where it's a magical process where You're sleeping for 3 hours and then you're awake for 3 hours, and you try to sustain this intention to do a magical thing. And his intention was that I would contact him in some way, or he would find me in some way, because he wanted me to join his board of directors in his company. He had no idea where I was because hardly anybody knew where we. I mean, we just got this place, and there's very few people in the world who know what we were doing or where we were. So he was shocked because his intention manifested. The door opens and there's the one that he's pulling. So I didn't feel manipulated. I think I have free will, but apparently not as free as I thought, because there I was opening the door for somebody who's trying to manifest me. So we both had to sit down for a while and breathe, because that was kind of shocking. So then the other part of the synchronicity is that during the months before all of this unfolded, I had selected a room in our office suite which would abutted the wall of his laboratory. It was like in my office, it was on the other side of the wall. I was drawing on a whiteboard on that wall what I wanted our laboratory to look like. It would have a shielded room, it would have a certain kind of chair, it would have physiological equipment, all a bunch of stuff. So I was drawing this on the board and sort of imagining what it is that we were going to build. And then this fellow, his name is John, he said, well, do you want to see what I have here? Yes, please. And so we walk into the shielded room with the special chair with the physiological equipment, which was on the other side of the wall from the whiteboard where I was drawing it. So the word draw is interesting, because as you're saying, it's like I am drawing something literally into being. I was drawing it in the sense of making a picture, imagining what I wanted, but I was being drawn to, within a matter of like 6 feet on the other side of the wall, the very thing that I was drawing. So in the magical world, the things like drawing and words like spell, like spelling a word, those concepts are not simply representations of ideas. They are, in some sense, a literal sense. The word is the thing.
The word
So
is the thing, definitely.
the word is the thing. So you spell a word. That's what spellcraft is about. You draw something in your imagination and you are pulling it towards yourself. So there's that story. So it fits into the notion of magic so well, which is why my current book is about magic, and my previous book was also about magic, because I realized, kind of to my shock, some years ago that, well, almost my entire career has been studying psychic phenomena in laboratory settings. That, of course, in the process of reading a lot of literature, I was reading literature in the esoteric world too, because there's a lot of hints there about what's going on. And in the Western esoteric tradition in particular, but you find it in the Eastern traditions as well, there are special powers that are said to arise primarily as a result of meditative practice. In the West, it's not usually called that, but it's essentially the same thing. There are certain mental states you can get into where your mind is interconnected with everything. That's the sensation that you have. And so we give that labels like telepathy and psychokinesis and so on. So I looked deeper into the magical literature, and I realized then that what we do in the laboratory and the synchronicities that happen in real life are essentially the same as what we do when we're studying psychic phenomena. So I've made this link then between psychic experiences and magical practices, and able to show more or less a one-to-one correspondence between the two.
So cool. So cool. Uh, and we don't mean magic pulling rabbits out of a hat. And so defining magic in this more magical way is so very important. And learning to make differentiations in the terms we use is very important. And one of the terms that we're I want to discuss with you is collapsing the wave function, because your research is beginning to indicate that consciousness, that focused attention, can do something similar to what measurement does in the laboratory for most physicists regarding light waves, photons, or electrons going through double slits. So you have shown that you can get little deviations in the outcome with focused attention by experienced meditators. But we need to know, and I know we don't really know, but what is the wave function that we're collapsing, however we're measuring or paying attention?
This idea was discussed by virtually all of the founders of quantum mechanics, because one of the primary differences between classical mechanics, which is a refinement of common sense, essentially, and quantum mechanics is that in quantum mechanics, a particle, a piece of physicality, doesn't have properties until it's observed or measured. And so it's kind of abstract to even talk about it in this way, but we in the everyday world, when we look at something, it has properties like color and weight and shape and all of those things that we think of as what an object is about. That's not true in the quantum world. So if you have something like an electron or an elementary particle, it could have a huge range of possible properties, but they don't actually exist until you measure it. And at that point, it is so-called collapses this huge range of possibilities into just one. And so this has been a long-term mystery, an unsolved mystery, really, within quantum mechanics. Like how could the world out there not have properties? Well, everything that we are aware of, that we are observing, we're automatically collapsing it just by virtue of the measurement of observation. And so, yeah, it looks pretty stable. It is stable. But now think of how much stuff is not being observed. And the
Yeah,
answer is
yeah.
almost everything there's not being observed, unless you imagine that there's a consciousness that's everywhere and observing everything all the time, which is
Which
possible.
some people do, yes.
Yes, there may be some sort of universal consciousness that is simply looking at everything. So most of the founders of quantum mechanics, I think only one exception I can think of, were philosophical idealists. And so that meant that they consider consciousness to be fundamental, more fundamental than the physical world. That is a viable philosophical position. It's a very different worldview than the way that science is generally thought of. Science is like all about materialism. But idealism says no, it's consciousness first. And so part of the questioning came about then was if elementary particles don't actually have properties in the way that we think of as large objects have properties, then the wave function was a mathematical construct that said that there's somehow in this quantum world, things are in superpositions of many, many states. Superposition means that it is literally every possible thing, that every possible property that it could be at the same time, all of them kind of all mashed together. And so the term that's sometimes used to talk about one aspect of this is entanglement. That was Schrodinger's word is entanglement, but that's an English translation from the German, and the German actual word was enfolding. So if you have a system that is like you take a drop of ink and water and you start mixing it up, it eventually will become just sort of a gray color, but it's actually enfolded into it. You can see, especially like if you're working with dough, you're working with a piece of dough and you drop in like a one drop of food coloring and you start working the dough, you are enfolding that color within the dough.
Oh, that's beautiful. That's
Yeah.
beautiful.
And it's different than entanglement because entanglement as a word we associate with something like tangled string,
Yeah.
like it's a chaotic mess. And it isn't. The very orderly form in which many, many things are mixed together and it might look like a tangled string, but it isn't. There are these connections. So when we look at an elementary particle, it exists in a superposition of many states, like all possible states. Something about the measurement of it then causes it to only collapse into one state. And so the reason why the double slit experiment can show this is because if you take a laser and you're shining photons through double slit to two tiny little slits, and then you have a camera on the other side that measures what kind of the light, what does it look like? It looks like bands of alternating light and dark. That's what the two little slits will do when they diffract the light. The mystery is if you know which of the two slits the photon goes through, that pattern goes away. And the new pattern that shows up is consistent with the idea that the photon is not in a superposition of states, but is actually only one state. So something about the knowing where the photon is going causes it to so-called collapse from its superposed infinite number of states into just one. So that was proposed by John von Neumann, by Wigner, by many of the founders of quantum mechanics as how do we get from this very abstract description of the physical world into the one that we experience. It's called
Uh,
going from quantum
one,
potentials into classical actuals. That's the transition.
when you know which slit the, the photon's going through, what does it appear like on the camera instead of two bands?
Well, if you don't know, it looks like a alternating light and dark bands. If you do know, it looks like a diffraction pattern. So the way it's sometimes shown, just for simplicity's sake, is like two bright bands of light, right? No longer alternating bright and dark, but just two bands of light, like they're little particles going through. That's actually not the way it looks. It's a diffraction pattern, which is different than an interference pattern,
Yeah.
but it's different enough so that you can very easily tell that you either have collapsed the wave function or you haven't.
And what do you see? Because that's you don't measure or you don't know which one it goes through, and you see alternating. When you do know where it goes through, then you're seeing two. What you're saying, I thought was two light bands. That's it, but it's not that. It's something else.
It's not quite two bright bands because the photon still gets diffracted. Like even going through one slit, the photon there's refraction that's happening. Or diffraction, so that it will get bent a little bit.
Yeah.
And so it's not two bright bands because that would suggest that it's not bent at all. But every time you're sending light through some kind of other medium or it goes through two little slits, it will bend a little bit. So you get kind of two fuzzy bands, and the
Mm-hmm.
fuzzy bands will overlap each other a little bit.
Uh-huh.
And depending on the distance between the two slits, it might just look like one big
White thing.
fuzzy thing.
A fuzzy thing.
Yeah, but
Okay.
the point is that it doesn't look like the other pattern. They're two very distinct patterns, and you
Okay.
can,
The
yeah,
two distinct patterns, the fuzzy or sharp, is way we can begin to distinguish them.
yeah,
So what you've done and try to get to is we first look at measurement, and there's been a lot of confusion to people about measurement equals observation, which in a way it is because you observe the result, but that's not what we're talking about. But in common language, measurement has equaled observation. They're almost used together when talking about this, but they are very different. Observation of result, okay, that's one thing. If you just have somebody in the room observing the two slits and the light going through, that's not enough. You
yeah,
got to have something else. So that observation doesn't do it.
right,
If you measure, and there's various measurements, so there are measurements that are different from just knowing which slit it goes through. There are other measurements that involve randomness in the measurement instrument that also have something to do with measuring the spin, for example, of the particle going through, of the particle going through it, and other potential measurements.
hmm,
So there are different ways of measuring. The simplest one is which one's it going through.
right,
Your when you have a machine measuring, then you get this kind of fuzzy but pretty distinct light, two light bands showing up. But it's fuzzy, so we'll use it. It's fuzzier depending on the distance between.
yeah,
But what you've done in your research is show that you can have a meditator focus on where the light is going through as if the concentrated meditative mind is doing something similar to figuring out which slit the light is going through. And you get some change in from the alternating black and white bands to something that approaches the fuzziness of what happens when you use a machine to measure. There's a minor deviation from what I've been able to say from when the meditator does it compared to what maybe a machine knowing where the light goes through. And that's a distinction that I'd like to know more about. It's in the direction of fuzziness, but still has some of the black and white band elements to it. And that, if I understand correctly, that is what you're suggesting, is that the meditator can do something to the wave function, but not what a measurement device can do, but it's in the direction.
Right. That's because the key in all of this is what can be known. Because you can take a measurement, but if no one ever looks at that measurement, the question is, well, is it actually known?
Yes,
Right? It's a tree falling in the forest and nobody's there to hear it. Does it
I
make a
know. Yeah,
sound? Well, the answer is no, it doesn't make a sound unless there's something there that can perceive something as sound.
right.
So it's the same in this case. If you have a device that is measuring where a photon goes, you send one photon at a time so you can tell it goes through the left or the right slit. If the device fires, say it's on the right slit, and you shoot a photon, the device fires, so it says, yes, I saw a photon. And you know that. Somebody knows that because
Hmm.
somebody has looked at the result of it, then you collapse the wave function. It's the knowledge of what happened that makes a difference. If nobody knows, and there is no way to know what happened with that detector, you don't get the collapse because it's as though the measurement never happened. Even though the device is there, you'll still get an interference pattern. So it devolves down to what can be known, and that's where you bring in meditators as a potential observation
And
system.
just to get it more clear, the if nobody knows the result, it's still like Bishop Berkeley and sitting there. There's a chair in the closet. If you don't look, you don't know where you don't know the chair is the chair there or not.
Right.
And that's a kind of difficult question to think about unless you have this God is looking at it, which is what Bishop Berkeley was suggesting.
Yeah.
That's what makes it there, but we're not thinking that way now. So eh, you know, you don't know, but how you know that you don't know and that it happened, that somebody else could have seen it, is an important part of synchronicity as well. Uh, that gets into like a lot of meta thinking for me.
Mhm.
And so I can't even say just because nobody looked to see what the result was, it didn't mean something didn't mean something didn't happen.
Yeah, after about three or four negatives in there, it's hard to begin to unpack what we think we're talking about. But this very issue is the reason why Einstein said, "Well, this is stupid," because it would suggest that the moon isn't there if you don't look at it,
Yeah.
and that's the way it's described sometimes. Well, what do you mean if you don't look at it, it's not there? Our experience certainly is that if you look at something, it's there. It doesn't disappear when you're not looking at it. Except at the elementary particle level, there have been experiments done which show that if it is not possible to know what a measurement is, well, then we don't know by definition. Nobody can know. And so
Well,
maybe the thing's working, maybe it's not working, we don't
and
know.
let's keep the cat in the garage or someplace for that one. We you got to open it up, and we don't know.
Right,
But let's then go to sending a photon through and
right.
having a measurement. With I don't call it a measurement there. It's a just like we know yes or no, this one or that one. If you can call that a measurement.
Well, so here's where the psychic part comes in. So one of the things we think we understand about psychic awareness is through extrasensory perception, we have the ability to perceive things at a distance. We can gain knowledge from a distance or from shielded areas. Well, okay, the interferometer is a sealed optical system. You can't just look at it. It's inside a box. So you tell somebody, use your extrasensory perception to gain knowledge about what these photons are doing. That's the measurement then, because now you're doing what you need to do, which is observe, in this case happens to be the mind's eye, and gain knowledge about what happened. Well, it's a very difficult task because we can't see a photon as it's flying through the air, and there's a whole bunch of things we can't do with our eye, but maybe you can do it with your mind's eye. And so if you found it too difficult, and I told this to our participants, if you find it too difficult to imagine what's happening with the photon, then just imagine you can mentally block one of the slits. Well, that would force it to kind of go through the other one. Or just like take the laser beam and nudge it over a little bit so it's going through one slit more than the other. Do any strategy you can think of in order to mentally interact with this system and either gain knowledge from it, which is like pulling information out, or pushing knowledge in, which is pushing information in, like pushing the beam around. So that's what we told people to do. And the reason why meditators did better than non-meditators is because they can maintain their attention on a task for more than 2 seconds, whereas the average person mind wanders almost instantly, and so they just can't do the task.
How do you know then that the meditator has had an impact?
We look at the results of we have periods where they're asked to interact with the system,
Mm-hmm.
and then equal periods where they're asked to withdraw their mind and do something else, but generally 30 seconds. So for 30 seconds, do this task. You'll get real-time feedback about the amount of double slittiness in the system because we can measure that pretty precisely in real time. And so they might see it as a graph on a screen or as a tone on a piece of music. And so they can use that as the target, like make this line go up on this graph. Well, the line is then linked to how much double slit pattern is actually there. And there's lots of different ways of measuring that. But so for 30 seconds, they do that. And then the screen or the feedback goes away, and they're asked to withdraw your mind from the system. Think about something else. Okay, now this next 30 seconds, again, engage your mind into the system and now withdraw. So we have a comparison between attempting to gain information from the device and not gaining information from the device. That's the comparison in the what the camera looks at, that pattern. That's what we look for.
And the pattern, again, is fuzzy, generally speaking, fuzzy versus interference pattern of black and white lines.
Yes, it's more
But
complicated than that, but in general, yes, that's what
well,
we're looking for.
I'm trying to have us be able to visualize.
Okay, so well, we usually say that it's alternating light and dark bands of
Yes.
light, which is correct. It actually is in the shape, it's like a bell-shaped curve, because whenever you shine light through a tiny little slit, it diffracts, so it's kind of fuzzy. It's diffracting out. But because you don't know yet information about what it's doing, when the photon goes through a slit, it's it doesn't have properties yet. It's still like a wave function. It is
Mm-hmm.
behaving like a wave. And just like waves in water, it's creating all these ripples
Yeah.
of one photon and another photon. So that's what creates the light and dark bands. Just like you would see if you threw two pebbles in the water, you'd find crests and you'd find troughs. That's what's going on. So if you do gain information about what a photon is doing, it will reduce the amount of rippliness, and so you'll still get light and dark bands, but what's called the fringes, the sharpness of those bands will decline.
Thank you for that. Yes.
That's what we're measuring is how sharp those bands are, and it
Okay.
is related then to how much wave structure is going on in the system.
And that, thanks for that, Dean, because I can visualize it now.
Yeah.
And there, what what I read was that that we'll call it the fuzziness again, just that they're not quite the black and white bands, a little less than that. Uh, is compare that to when you actually have a machine measuring which slit it goes through.
Right. So we can talk then now about fringe visibility because we were talking about how sharp these bands
Yeah,
are.
yeah,
So if you have a detector and you are recording it in some way so that people are looking at it, so knowledge is really being extracted from the system, those fringes will completely collapse. They will go away entirely. So what the mind is able to do is not as good as knowing for sure, like 100% sure that the photon went through this way,
yeah,
that will collapse it all the way down.
yeah,
And so what we're seeing are tiny little reductions of the
yes,
fringes. And
yes.
so, people say, well, why don't it collapse the whole way? And the answer is very clear that ESP is not exactly the same as measuring something with an instrument. That's why. And so do you find some people are much better at this task than others? Absolutely. So some people are really, really good at being able to do this. Even in those cases, they can't collapse it all the way down. They collapse it more than somebody who doesn't have very good control of their mind, but they can't collapse completely.
It's it's how good are they at fuzzy is the way I'm going to suggest say that.
Well,
Uh,
it's kind of a objective way of measuring how good they are at remote viewing or clairvoyance.
yeah, yeah, and there might be a way of saying percentage of fuzziness from black and white to complete white. So I assume that you are able to do some kind of percentage estimate of how effective different meditators are.
Yeah. So there's two measures of interest. One is a statistical measure of when you see a small change in the fringes, what is the likelihood of that by chance? So that's where we start talking about
Good,
probability
good.
values and so on. So from a p-value perspective, it's very, very small p-value, means it's not happening by chance. The magnitude of the effect is a very, very tiny fraction of 1%. But we're able, I mean, there's often a conflation between does it exist versus how big is it?
Yeah. Yes,
Well,
that's true clinically too in measuring outcomes, and p-values are increasingly notorious for being not practical. It's
yes, yeah. So you could have an effect which in a clinical setting is not practical at all,
yeah,
but could have a very high p-value. So you
yeah,
know that the thing exists. It's just you don't, well, in basic science, we don't care what the efficacy is. That's not the issue. The question is, does it exist? The
okay,
answer is yes, it happens. It's not big enough to be able to turn it into a switch. It's not that good yet. But that's not the issue. When you transition from basic science into applied science and into engineering, then the efficacy issue is really important.
yeah,
So we know that this happens. It is, at this point, we don't know enough about how to turn that into something which is practically useful.
okay. And what you've done in the science of magic is take that p-value that you can do a little, you can make a little bit of a change from an efficacy perspective. And that p-value suggests that the capacity to have for mind to influence matter is exists. And that's the primary intention of what
Right.
your research implies practically. That's a practical application here out in the real world.
No, it's not practical yet.
No,
It-
but from what I understand, you say mind can create reality.
yeah,
You take that p-value, which is not efficacy, but a p-value,
it's an
and seem to
existence.
generalize it to what goes on in the world.
Right. And so the reason why I'm not too concerned about efficacy, which is practical application, but I am concerned about existence is because it addresses these fundamental issues about how does
Yeah,
mind
that's,
interact with the physical world.
yeah,
But in the laboratory, every time we do an experiment, it is a compression of what actually happens in the real world. We're intentionally compressing down and operationalizing what somebody does so that we can gain very high confidence that something exists because we don't care yet about efficacy. So you transition now into magic, which is all about a practice
Yes.
with very high motivation, right?
Yes.
People are not doing magical practices because they want to find a 10-cent piece. Who cares? They're looking for love and for sex and for power and for big
And
things
for a laboratory too, that helps.
and for yes, in a laboratory. So they're looking for real world high motivation things which we're not ethically able to do in the laboratory.
No, you're not. So because it happens in the laboratory, you make a generalization, I think, into efficacy in the real world.
Yes, yes,
And
and
that's a
yeah,
leap that I'm questioning.
yeah, no, that is the leap from what we see in the laboratory as an existence proof, essentially,
Yes.
into, well, if that is true, then under conditions of very high motivation, maybe it happens like you get really big stuff happening,
And
like
that's
real,
true of synchronicity. When you really want something, like
right,
a lab space or Dean Radin to show up, stuff happens.
big
High
stuff,
emotion is highly correlated with synchronicity
right,
happening. It's one
right.
of the it's there. So we're able to agree on that. And I'm going to go back to your wonderful story. And in the middle of your story, you said I went a different way
Yeah.
and discovered. Going a different way is a key way of increasing meaningful coincidences.
Hmm.
It's just part of it. It goes along with high emotion or a drive. So you went a different way. And the way I think about this is more in a human GPS, almost clairvoyant way, that you were looking for something and you could imagine where you needed to go, which I call human GPS, and you took the wrong way, which is often the way you get there. By getting lost, you find what you're looking for.
Yeah.
So that it's in my view, it was there, and you kind of knew it. It's a similar idea to a probabilistic universe, that there are things out there to be found, but I think we can discover those things somehow, and we can call it magic. We can call it clairvoyance. We can call it just being alert and curious and motivated, which begin to overlap with what you're talking about too.
Right. It's also one of the reasons why travel is useful because you're exposed to something that you weren't paying attention to before.
That's right.
You always do exactly the same thing again and again. You become a nerd to it, and after a while, you don't pay any attention to it at all. So it's true that especially if you're on some kind of mission, a magical mission, yeah, do try everything. That's why just somebody asked me they're going to do a radio show and they want to play music during the break, and they said, "Well, give me a song to play." So I said, "Well, play the song "Try Everything" by Shakira, which was in that movie Zootopia, I think. And I like that song because it's all about I want to do this, but I keep failing. Well, try everything, keep doing different things constantly because eventually something you will encounter something in a synchronistic way that allows you to succeed. And
Yeah,
so,
yeah. I call it with a parable, the dog that trots about finds the bone.
yes,
Especially if the dog trots around a butcher shop.
that helps.
It
Yes,
helps. So try everything, but maybe there are better environments to try things out in. So let's apply that curiosity, drive, movement to your research. How do they come together?
well, research involves trying everything, especially when you're working at the edge of the known. Almost by definition, most of the time you're sort of flailing around in the dark because we don't know how these things work. There are a whole bunch of different theories, and there's lots of different ways that you can do experimentation. My preference is to do a huge amount of exploratory work. Now, there other scientists that have different predilections. Some people like to nail everything down. This is exactly what we're going to do. We're going to pre-register it. We're going to do this. It's a confirmatory experiment, blah, blah, blah. There's an advantage to that because if you do the experiment and it works, then you get pretty high confidence that you think you understood something.
But you made a good guess too. That's
Well, you try to make a design of an experiment that's based on some prior reason for why this thing ought to work.
yeah.
I don't think we're anywhere near actually understanding yet how mind and matter interact. So my predilection is to do lots of exploratory work. And then somebody else can replicate it, somebody else can lock it down, they can do that, but that's not what I'm interested in.
Yeah.
I do like to try everything.
You're a cutting edge guy, man. That's what you do.
Well, that's what keeps me excited about this,
Yeah. Yeah.
trying new things. And it's partially with an underlying notion similar to what you were talking about, that you want to find the bone. And if you keep doing the same thing over and over again, you're not going to find the bone because you've already gone down that path. So, okay, let's try different things. So most of what I do then is I'll do an experiment. If I'm lucky, I'll get some interesting result. I will not do that same experiment again unless I really have to, because that gets done. I did that. I don't need to do that again. Other people though will say, oh, no, we did this. We better repeat this like 1,000 times now.
You let other people do that. You're going to go on to the next thing. I mean, that's
Well,
you're
yes,
you're you're a dog trotting about, looking for the next bone. And
I'm looking for the bone. And other people then can go find the bone where I found it. And
and
fortunately they do, right? Because I come up with something saying, whoa, this is really good. And then I wait for other people to replicate it, not simply because I'm not interested in replicating myself, because I have done
it's
that.
boring. It's boring.
It
I
is
don't want.
it is
I don't want to
boring,
do that again. You
yes,
just like
but
trotting about. That's the way it is.
yeah, it's not always boring because sometimes you get a crazy good result and you can't
I
quite
want to do it
believe it.
again. Yeah.
Yeah. So, but it's important because anybody can come up with an experiment that has a flaw in it, and you may not know it's a
Yeah.
flaw. So you want somebody to completely independently do this thing again.
Yes, in a different place at a different time. Yes.
Yeah, even better, a conceptual experiment. Like if that worked, then maybe this ought to work too. Well, sometimes you don't get the concepts exactly right, but nevertheless, you start getting a convergence towards something saying, well, X and Y go together and you get Z,
Yeah, it's,
like that.
but here I ask about the experimenter effect. That you, when you had those experiments with the slit and the meditators, you had an idea in mind about what you wanted from that. I mean, you couldn't get away from that. So
Well,
how did that influence what happened?
I was replicating what other people had reported. So the first actual study using a double slit for this kind of experiment was published in 1998. And there were two labs involved. One got a significant result and the other one didn't. One was at York University in Canada. The other one was at Princeton University. Well, I knew the people at Princeton. I had confidence in their ability to do the experiment, and so they got a significant result. And then nobody did anything for 10 years. And 10 years go by, and I'm thinking, somebody ought to repeat that because if that's true, well, that's really important from a physics perspective.
Yeah,
And so I started using interferometers. I first used a Michelson interferometer and then a double slit, and now I'm using diffraction grating. They're all basically the same idea. They're about wave interference. And so I did that first experiment, and holy smoke, it worked. So I became interested and said, let's try this with a double slit. Oh, that works too. And then finally, people began to replicate it. So there are 6 labs so far that have tried this, including the first 2. 5 of the 6 report significant results. The results are not always in the direction of a collapse of the wave function, which is really interesting. Because if you keep doing experiments and only get what you predicted, you start thinking, I'm either making mistakes or the universe is trying to tell me I'm not asking the right questions, which is much more exciting.
yeah,
So we do the experiment, and instead of seeing a collapse of the wave function, we see that the fringes get sharper. But people are doing the same task. Well, how in the world does that work? That doesn't mean that something is collapsing. It means something else. Well, there is another quantum effect called quantum Zeno effect. which is much, much closer to the notion of a psychokinetic effect. In other words, I want this
Yeah,
to happen.
yeah.
This can go in any direction you want. And so the quantum Zeno effect is in two flavors. There's a quantum Zeno and an anti-Zeno. Well, look at the quantum Zeno effect says if you have a quantum object and you are measuring it repeatedly, again and again and again, it freezes its evolution. So,
Ah,
and by freezing the evolution, it means that you can maintain a certain coherent order in that system. So
because
it's
you
not,
kept doing it so many times.
yeah.
Okay.
And the anti-Zeno effect is you can accelerate its evolution if you're measuring it at a slightly different pace. So you can either freeze it or you can accelerate it. From the point of view of an experiment, what that would do is sharpen fringes or make the fringes more fuzzy. And so this is yet another mystery that we didn't even think of this before we started doing these experiments, but it is each time you get a hint like this of where you need to revise what you think was going on, it's much more interesting because now not only can we maybe collapse a wave function, we could also make it more wavy. So it says that whatever's going on between mind and matter is way more complicated than even the founders of quantum mechanics were thinking
Well,
about.
this latter thing you're talking about suggests once a pattern gets established, it continues. There's a kind of a momentum to the pattern. If the same pattern repeats itself over and over again, it begins to look a little bit like morphic field and morphic resonance.
Sort of, yeah.
Sort
In,
of.
in
Okay.
this case, it's about extracting information from a system repeatedly. And so it's like you do a measurement once, the system changes a little bit.
Mm-hmm.
Measure it really quickly again and prevent it from changing. That's how you can freeze the
That's how
system.
you freeze it. Yeah.
Yeah. And then the changing the frequency, like it can collapse a little bit and you just wait the right time and then measure it again and it collapses more. And that's how you can accelerate it. So
Uh,
these are all
uh,
well-known things from
it,
physics.
and it just makes you crazy with wonder to see how that happens.
Yeah. And
So,
well, and also even crazier that you can think, well, the mind is involved in this in some way
yeah.
directly. Well, that's interesting. So you can see then if you spend time thinking about this stuff and you see it in a laboratory that the notion of esoteric magic as a real thing doesn't seem quite so strange anymore.
It doesn't, especially if you wake up for 3 hours in the middle of the night to concentrate on a what you call it Dean Radin thing showing up somewhere.
Yeah.
That's concentration for sure.
Yeah.
That's the kind of thing that I'm interested in because I'm a psychiatrist. I do psychotherapy and study synchronicity. I'm very much interested in the mind's interaction with the environment. And so that's where I come up with the dog that trots about curiosity, emotion, because these are repeated patterns within increasing frequency of synchronicities. So the way I start thinking about this is a little bit like a probabilistic field.
Mm.
There are all kinds of things out there, but I need to be able to pay attention to them out here in the real world. So this is the p-value. Now it's going out to the efficacy part of this and trying to take what you're describing into helping to know better how people can increase their meaningful coincidences.
Hmm.
And so we're getting near the end of this. I want to see if you'll get out of the lab as we've been talking most of the time and get us out into the magic of the real world.
Well, that's why your listeners need to buy my latest book because about half of the book is all about the evidence that's the existential question. The phenomena exist. The second part of the book then is saying, well, basically, so what? What
Right.
can I do about it?
What's so
Well,
what?
that's where it's useful to go into magical practices. So these are things that have been around for millennia. It's methods that people have used in order to try to make these effects active in the real world, to make them effective. So I mentioned half a dozen different techniques part and also the factors that make a difference for making these things work. So they're all along the lines of what you're saying. You need motivation, focus, clarity, all of those issues. And then the practices help. The practice, like a sigil magic is all about making a symbol, and word magic is about writing the words and so on. There's very simple things, but they are useful because they focus the mind and gain clarity.
And gaining clarity, for me, gaining clarity about knowing what you want. So when you see it, you know that's what you want.
Yeah. If you don't have a goal, you don't know whether you've made it or not, right?
Well, Yogi Berra, you're kind of paraphrasing him.
Yeah,
If you don't know where you're going, that's where you're going to go.
that's
It's the
right.
same idea.
So let me add one other thing. So last Friday, I gave a talk at Harvard Medical School
Wow.
on these issues, on the evidence for psychic phenomena. At the end, I talked a little bit about magic. I
Did you
was,
do it in their amphitheater in the medical school?
I did, yes.
It's a wonderful place to talk. I've been there
Yeah, I mean,
myself.
it's like 600 or 700 person amphitheater. It's big.
Yeah, it's great.
And we estimate about 400 people were there.
Wonderful.
And so there were professors and residents and everyone you'd expect to be at Harvard. So the conference was on consciousness beyond the brain. And so it was all about things like the anomalies of near-death experience and out-of-body experience and psychic experience, all of that stuff. So it was appropriate to talk about these topics. I asked the organizers, though, can I talk about magic? Like pushing away from laboratory p-values into actual efficacy. And they said, well, you don't want to cause scientific panic. You don't want to cause like a riot in the audience. So the way I handled that was
A riot
I,
in the audience. That's, I mean, they're so sedate. When I was there, to see that would be,
no, my sense of it was though I present these kinds of things to most audiences in the sense of here's an experience that can happen, the feeling of being stared at, precognitive dream, whatever. And then I'll say, well, how many people in the audience have had this experience?
that's good.
Half the audience,
Yeah, it
so they
does.
immediately are understanding, oh, that's happened to me.
Yeah,
Then I'll say, well, here's how we test that in the laboratory to see what's actually happening.
very good. Very
Yeah.
good.
So it pulls people into it. And so at the very end, I say, well, I only had 30 minutes to talk.
Oh, that's all?
Yeah, 30 minutes. Well, it's part of a conference. So,
Okay.
each plenary speaker at 30 minutes. So I give my talk and I'm pulling them into the story. And then at the very last slide, or the second to last slide, I said, I have ideas about how this actually works,
Uh-oh.
which of course they want to know at that point, like how in the world can this stuff be real?
Yeah.
Sorry, I ran out of time. But if you're interested in
Read
learning
my
about it,
book.
I have this book which is coming out. Yeah, and then you can learn all about it. So a colleague in the audience said at that point, every other person picked up their phone and was taking a picture of the slide because they had the cover of my book on that slide. So my strategy then was that I wasn't talking about magic. I didn't want to panic anybody, but I pulled them into wanting
Oh,
to at least look at a book. So
that's great. That's
yeah,
great. Well, with that wonderful ending, we'll bring our podcast today to an end. And I thank you very much for going through the details of collapsing the wave function. And the entanglement idea is really an important translation that you just meant. Enfolding.
yeah,
It's like the idea of different orders of implicit, or explicit orders. It's something like that, but I can
well,
see the picture of the dyes, of the colors coming together and having them be enfolded with each other. Because entanglement has been now used as an interpersonal thing, that
mhm,
there are entangled families,
yeah,
definitely,
yeah,
and that they use that as a metaphor to talk about telepathy and other things, and it's not right.
yeah. It's like the difference between scrambling an egg and taking a piece of dough and layering it upon each other. So it looks scrambled, but it isn't. Like, like certain kinds of pastries are made that way. So it has all these layers in it, and it looks very complicated, but it's basically one thing just put into a new order.
Beautiful, beautiful. Well, I'll see you on a podcast next week.
What is the podcast next week?
It's from England. Uh,
Oh,
Teresa is her first name.
oh yeah, Teresa Chung.
Yeah, Teresa Chung.
Oh,
I've been on there before with her, but you and I will be together in the last half an hour,
oh, great. Okay, good.
and perhaps continuing this discussion with her. So,
Well, in fact, it was that show that asked me what music did I want to play.
ah,
So I said, well, try everything. That I like that song, but it wasn't long enough. So instead, I said, okay, my second choice would be "From a Distance." Do you know that song, "From a Distance" with
no,
Bette
that's a
Midler?
good. That's the title we're all after here. Yeah, that's good.
Yes, it's a song that the world needs because basically it's that from a distance when you look at the Earth, you don't see war, poverty, continents. You don't see anything like that. So from that perspective, you're looking at it saying, what in the world is going on the surface? What are those people doing? It's a beautiful planet. And that's more or less what the experience was of the founder of our institute, Edgar Mitchell,
Yes,
coming back from the moon to the Earth,
yes.
seeing the Earth as this perfectly wonderful blue ball where you have all this conflict going on underneath. And, there's just the contrast of that was one of the reasons that inspired the
And,
creation of our institute.
and you, bless your heart, are so much a part of trying to bring us into that one world perspective.
Yeah,
And and I thank you very much for your work. And I look forward to talking with you next week.
very good.